Hi, everyone. Today, I'm going to tell you about JavaScript in near space. It's actually based on a project some friends of mine and I have been toddling around with for about a year, on and off, and I was just reminded that it's actually, yesterday was the anniversary of the first balloon my friends attempted to launch that was actually, it actually met an untimely death about 4 feet off the ground on a stray beard hair, so just FYI. My name is Pawel Szymczykowski. If you're not familiar with the pronunciation of Polish names, I've provided a visual pronunciation guide right there for you. So if you can say Pa, Bell, Shrimp, Chick, Coffee, Ski, we'll call it close enough. I'm from Las Vegas. I work for a small company called Wedgies that does online polling. And I'm at Makinai on Twitter, but don't follow me because I don't really tweet anything interesting. If you've heard of me at all for any reason, it was probably for this guy here. This is SumoBot Jr. It's an open source robotics kit I designed for NodeBots Day Las Vegas. It kind of picked up a little steam and started popping up at a bunch of NodeBots events all over the world. And eventually, Microsoft used it for their build event last year to demonstrate Windows 10 on Raspberry Pi 2, and that was cool, but weird. It was cool. It was cool. I also contributed a chapter to this book here, JavaScript Robotics, among a lot of other much cooler people than I am, some of whom are here today. But I did a chapter on Delta robots. It's kind of like the one that's on the cover there. So why space? Why indeed? For a lot of us, the answer is just like, well, fuck yeah, space is awesome. But for others, maybe I'll try to quantify my reasoning. So space is just this sort of like vast, endless thing that holds all of these mysterious secrets. It's literally like no place on this earth. And I think as a species, we just kind of yearn to explore the unknown. In space, it probably holds like the mysteries to life itself. Who knows? Also, I probably watched a little bit too much Star Trek: Next Generation when I was a kid. That probably had something to do with it. Rubbed off on me a little bit. But it was, maybe it was my generation's like Apollo missions. When I was a kid, there wasn't a ton of things going on. Shuttles were pretty common, and Ronald Reagan was trying to build massive space weapons, and that was kind of like not cool. But TNG was kind of a nice and humanitarian mission, that type of thing. So it's probably a good role model as anything. Plus, I noticed that there's something missing from the sort of like NodeBots ecosystem. I don't know if you've seen a lot of these before, but the first one there is NodeBots. Those are like the wheeled ones. Then NodeBoats, really popular at JSConf US in Florida. We have node-powered submersibles. OpenROV is a submersible. And a remotely operated vehicle underwater that you can power with a Node web server. Node copters, Node rockets, they're almost to space, but not quite, because they're powered by compressors. So you need to go beyond that and up into space, maybe. I think it's time for some JavaScript in outer space, or not outer space, near space, let's say. It's more achievable. And finally, I think just because it's a challenging and interesting problem, it's hard. And there's a reason why it's kind of the domain of countries and well-funded private companies like SpaceX or Virgin Galactic. This is a side project on a totally different scale, but it's still hard. It takes a lot of different disciplines, a lot of different areas. That includes electronics and programming and building things and radio operations and like car chases and all sorts of things. A lot of things can go wrong, and they often do, and take a long time to figure out. But that's what makes it interesting to work on. That said, I do think it's definitely a possible thing to do, as long as you set realistic goals and are pretty persistent. Speaking of goals, let's figure out what those are, at least for me and my group. Step one, kind of a no-brainer, is get really high up in the air. There are a lot of things that go up in the air. Drones are one of them. They don't quite go high enough to be interesting. Some of the new commercial ones do go pretty high, but at least in the United States, we're not allowed to fly them higher than maybe 120 meters or so. There are industrial, not industrial really, but like high-end model rockets. I'm talking about not the little Estes kits you can get in cardboard tubes, but they have 20-foot ones that have massive homemade engines, and they shoot up and they go really far. They're not in the sky very long, and they go really fast, and they tend to do things like explode, so it's not really in my comfort zone. What about balloons? Well, it turns out in the United States, sorry, I don't know about the regulations in other countries. I know there's a lot of different countries represented here, but in the United States, we have a federal guide of regulations, including FAA guidelines. And there's specifically a section there about moored and unmoored balloons, meaning attached to the ground or not, for photography and science experiments. And they're regulated, but the regulations aren't that crazy. They're pretty reasonable compared to things like drones right now, which are new and scary. High-altitude balloons have been around since the 1700s, so they're kind of lax. They have things in there like, don't launch your balloon over a city or near an airport. It's kind of a no-brainer. Things like, don't launch on a day with low visibility, so airplanes know where you're launching from, so they don't run into the thing. It's not really a problem in Las Vegas. There's hardly ever clouds in the sky. Where I'm from, over there, it's just very dry and blue all the time. Things like, don't trail anything for longer than 50 feet from your balloon. It's probably not a problem. We're going to do something very short compared to that. And make sure that, that whatever's trailing can break less than 50 pounds of force. So just in case something like an airplane runs into it, it'll just burst apart and hopefully be harmless and nothing will get entangled. Very reasonable. You also have to alert the air traffic controller about a 2-hour launch window, when and where you intend to launch. And then finally, you have to have 2 ways of getting the balloon down. Allegedly, one of them is it went too high and the balloon popped and it came down. So that's kind of in the bag. Pretty reasonable. However, do they go high enough that we can say we've gone to space? In fact, yes. Wrong slide, sorry. So these high-altitude balloons, or weather balloons, as they're also called, can go up to 37 kilometers. And there's an area of our atmosphere called near space that starts at 20 kilometers, between 20 and 100 kilometers. And it's at that point that you can start to see the curvature of the Earth. It's really interesting. They're right at that 20 kilometers up, there's a zone known as Armstrong's limit, at which point humans can't safely go up there without a pressure suit because the pressure is so low that that water will start to boil at body temperature. And it's exactly what I'm looking for, something alien, strange that you can't see here, and it looks beautiful. By the way, it's not named after Neil Armstrong, the astronaut. It's named after another Armstrong, Harry Armstrong, who was an Air Force doctor who discovered this. So obviously the best thing to do would be if you could go up there yourself and experience it. But that would probably take a lot of balloons, and I don't have a pressure suit or even like a press business suit, so that one's out. The next best thing might be to send up some sort of sensors and collect interesting data to sort of see what it's like up there, poke around, essentially build a probe and experience it, have a sort of an out-of-body experience. So that's what we'll do. And we'll use JavaScript. And why JavaScript? Indeed, well, this is a JavaScript conference, so I wouldn't be giving this talk if it wasn't JavaScript. But a lot of it has to do with this piece of software here, Johnny 5. It is a fantastic fantastic piece of software for controlling hardware using JavaScript. It's written by a man named Rick Waldron, and I pretty much credit it for me getting into JavaScript development at all. Before that, I was putting along happily with Java and Ruby, and then I saw node bots and played around with that JavaScript, and was just like, all right, this is what I'm going to do now. For a very long time, or a pretty long time, I guess, Johnny 5 only worked with Arduinos. Then one day, and that's fine, but maybe not so good for our application here. You'd have to tether the Arduino to your laptop using like a USB cable, and you probably don't want to launch that up into the air. But then one day, I think it was maybe 2 years ago or so, Johnny 5 got support for pluggable I/O modules, and it could support pretty much any hardware somebody was willing to write a driver for. And then a man named Brian Hughes came along and wrote this Raspi I/O package to support Johnny 5 on the Raspberry Pi, which is fantastic. It meant it would run standalone. You could do pretty much all of the same things you could do with Johnny 5, but it was suddenly untethered, and you could just run it on this little computer. This one's a model, I believe it's an A+. It's small. It uses less power than some of the other ones. Perfect for the task. Oddly enough, Brian Hughes is next door in the sidetrack giving a talk on JavaScript community and not robots, but he'd be equally capable of both. If you've done any work with like Arduinos or Johnny 5 or any of this stuff before, you might be, especially if you just poke around a little bit, you might be familiar with sensors that hook up using maybe two leads. One is like a ground and one is a power. The sensor pictured here is an MPU 5060. It's actually a 6-axis accelerometer and gyroscope. So at the minimum, you would need, if you were going to hook this up in the traditional way, you would need 6 signal pins and a ground pin, but there's other sensors on here as well, and that could quickly get out of hand if you wanted to add support for more things. Luckily, this particular sensor and a lot of the more complicated sensors have an interface known as I²C. That only uses 4 pins, just the first 4 on that right side. And I²C devices are addressable, so you can chain them together and still only use 4 pins. It's very convenient for this purpose. So like USB. You don't need to know anything special to use I²C devices using Johnny 5. You just sort of declare them and set up a listener for data events on each sensor. You don't even have to look up the I²C device address yourself as you normally would. If you're home rolling, Johnny 5 will actually look that up for you. And once we get that data, we'll probably want to store it someplace useful so we can look it up later and reference it. As a lazy web developer, I tend to want to use tools that are already there, tools that I'm familiar with. Winston, if some of you develop web apps in Node, you might be familiar with. It's actually a logging framework that supports different log levels. You'd normally use it to like log errors and debug statements from your web app. One interesting thing that it supports is JSON logging. So you just set that flag of JSON to true, and you get nice JSON objects that you can parse pretty easily later on. And all we have on the bottom line there is an interval to every half second look at the status of the current data block, which we were setting with the data events, and just log that. This is a sample of what that might look like. This is from a drone test flight I did a couple of weeks back, I believe, or maybe just, no, not that long ago. And so this is one line. It has all the data for the 3 sensors. Oh, the ones that I had chained up there were a thermometer, a barometer for temperature and pressure data, an electric compass for heading and bearing data, and the accelerometer itself. So it's quite a bit of data, and boom, it's like a simple and very scientific-y looking data logger, I guess. Another piece of data we might want on there is visuals. Using a Raspberry Pi camera for this is kind of a no-brainer. It's very light. It's very cheap. It's about maybe $30 US or something. And there are modules for it as well that just wrap the native modules on the Raspberry Pi. A bonus of using an onboard camera versus an external one is that your timestamps on the data and the pictures or video will be in sync automatically because they're using the same clock. Then step 3 is probably the hardest one. It's getting everything back safely. Because if you don't get your balloon back, all of this is for naught, and you've just spent a lot of time and energy on like a 10-second show as you watch the balloon float away forever into the sky. So this one's important. What comes up, or what goes up must come down, but it won't always come down where you expect it to or as softly as you'd like. So that's what we're trying to work around here. And that's something that has a lot to do with planning. The trajectory your balloon is likely to take will vary greatly on the weather and time of year and the weight of the balloon and a lot of complicated things that are hard to figure out. But luckily, these lovely folks at habhub.org, HAB is a High Altitude Balloon Hub, have created a calculator to make it a lot easier. Essentially, you figure out how much your payload weighs. Payload is a fancy term for the box that's on the bottom of the balloon, the thing you're trying to lift up. How much that weighs, how large your balloon is. I skipped over a little bit of the balloon stuff, but basically the balloons are latex balloons. They're larger than standard balloons. They're very thin, which is why a beard hair could pop it. Normally you wear gloves. And they come in different sizes, but rather than selling them in diameters, they sell them in weights. So that's just how much the balloon itself weighs. But it still applies that a 650-gram balloon will hold a lot more gas than a 250-gram balloon. You can fill them with helium or hydrogen. Again, hydrogen is more explodey. Helium is more expensive, and there's a world shortage, but I choose helium because I don't like explodey. And so you put in the size of the balloon that you have, how much your payload weighs, and it'll tell you how much gas to put into your balloon and how much lifting force it should have. Once you have the rate of acceleration, which comes out of this, and the burst altitude, which is how high it'll go before the balloon is likely to burst, you can put it into the bottom boxes there and pinpoint a starting point on the map, and it'll graph out where it thinks your balloon will go and at which point it will explode in the sky. That's that sort of red dot in the middle. And so you'll want to, for that day, pre-plan where you're going to launch your balloon and where it might end up, hopefully not on top of a mountain or inside of a secret military base. So do that before you launch. Of course, that's not foolproof because, I mean, it's kind of an educated guess. Weather patterns change. It won't cover the case where maybe a giant bird has abducted your balloon and suddenly it's miles off course, or maybe it didn't pop the way it should. So an ideal thing to add would be a GPS tracker, just so you know where it is, but you still need to get the data to yourself. You're on the ground watching a balloon float away. If you recover it, you'll know where it went, but that's not very useful while you're trying to track it down. Normal radios, Wi-Fi, commodity RF modules like the XB don't really have the range, but shortwave radio does. And it, in fact, has a specific protocol for this called APRS. APRS stands for something, automatic package, something. Anyway, it tracks things and sends their positions over a shortwave radio signal. It does this by, shortwave radio are kind of like the ham radios, you know, usually the people who hang out in their basements and they're talking to people and bouncing their signal off the ionosphere and trying to figure out if they can get to Iceland from Idaho. Those guys. It does that by, the APRS uses kind of an encoding called AFSK, audio frequency shift keying, that encodes the data as, if anybody's old enough to remember using like a dial-up modem, it sounds kind of like that. That type of thing. And there's another protocol underneath that that's a lot like TCP/IP. It's called, I believe it's, I don't remember the name of it exactly, But there's a routing protocol, and then it sends bits of information. So it could be theoretically possible to rewrite that on top of, in JavaScript, using Johnny 5, adding support for the GPS radio, adding support for a transmitter module. It would take a bit of effort, though. And there's already a really nice schematic and open source software for this called Trackwino that's made for an Arduino. So I figured I'll just add that and talk to it over serial to the Raspberry Pi, so we can still get location data from it. You'll notice there's a call sign there. Because shortwave, the APRS frequency is regulated, you do need a ham license to operate on the signal and to broadcast on it. So my friends and I all just sort of crammed for the technician class radio exam, and maybe a week or so, crammed it and all passed. Wasn't hard. The exams are all available online, but we walked away knowing really nothing useful about ham radio or how to operate it, but we had call signs, and that's all we really needed. And the way this APRS works, as I mentioned, it broadcasts this blip out on this specific frequency, and it arrives at a special type of station. These stations are all over. They're called digital repeaters. They will listen for things that are addressed to APRS. There's a sample packet there below. The KG7OXY is my call sign addressed to APRS. So these digital repeaters will pick it up and then route it through the internet, where a service like aprs.fi will pick it up and plot it on a map. This is the area around my home in Vegas, and all of those little dots are either stations or moving cars or airplanes that have APRS enabled, or I don't think there's any balloons. There's some repeaters on there as well. So if you have that and you have internet signal, you can launch your balloon and sort of chase it. Grab some hiking boots, drive as close as you can to where you think it is, and hike the rest of the way. And then goal number 4 is actually doing it. So that's the tough part. Like, a lot of things that involve space are usually behind schedule and over budget, and this one's no exception. We haven't successfully launched this thing yet, but working on it. This is what the completed payload looks like. It's got all of the sensors there, the Raspberry Pi camera, the Trackwino module. If I didn't mention before, the module is called Trackwino, the open source kit. And there's an antenna and a USB power thing right there. This is all mostly complete. There's some issues still with talking between the Raspberry Pi and the Arduino. I had a little bit of a conversation about that with Brian yesterday. Maybe we'll continue that today. And there's also the worry about the antenna reaching digital repeaters, which, if it's high enough, it should work, but we'll see. Been doing some test flights using a drone like this. It's good to sort of test how the things will hold up once they're up there, especially as far as the radio. So it's a good way of testing it. We're still working on this. The next launch window we're looking at, these are like weekends. A lot of us, or actually one of us lives in a different city now, and we all work at different places. But we're looking at October 23rd for the next one. So we'll see how it goes. And there might be a sequel to this talk at Thunderplanes JS, where hopefully there'll be a section about, like, well, what do you do with all that data once you have it? So we'll see. Maybe see you at Thunderplanes. And that's all I have. Thank you. These are my friends working on this with me.